All right, this is part 3 and our final part on the Learning Data Science from Scratch video series. In this video, we're going to use data science to make some predictions about our population based on the data that we have. So let's get started. So first, let's just create a new notebook here and we'll just call it real world because we're going to do some real world analysis here. And then let's go ahead and start where we finished in the last video with this distribution plot that we had. So we'll go ahead and run this. And if you watched videos 1 and 2, this code should make sense to you here. Let's scroll down and what we'll see here is our data frame. And then below that, we'll see the histogram that we had and the box plot, right? With the mean, median, and mode all right in the center. This should look very familiar to you. Okay, so now what we want to do is look at a different set of data because we've been looking at grades. So let's look at study hours. So to do that, let's call our show distribution function. And this time we'll pass in the data frame of students and the study hours instead of the grade. And we've got a capital T, which is wrong there. Let's go ahead and run this. And let's look at the histogram and box plot for this one. All right, so this histogram and box plot looks quite a bit different. So you can see that the whiskers on this plot start at about 6, and that 0 over to the left here on the bottom indicates that we have statistical outliers, less than 6, but they're outliers. And an outlier means that it's not representative of the normal sample here. And that could be for a variety of reasons. So if you had a 1 here, 1 hour, maybe that's a typo. They meant to put 10 hours in the data set and they got 1. Or maybe there's something else that caused the student to only study for 1 hour. We don't know. But we can safely say that this is a statistical outlier and it's not representative of the rest of the data in our sample. So one of the things that we can do here is we can just remove it. So let's go ahead and take our students, right? And then from that, let's pass a filter. You should remember this from the first video. And we're just going to take it where the study hours is greater than 1. And then we want from that the study hours. And this will give us the study hours that are greater than 1. And then let's go ahead and do our distribution again. And we'll pass in that new filtered set of study hours. And now our box plot goes all the way to the left and the right, right? Extends the whole range because we've gotten rid of that statistical outlier. Now, normally in data science, you don't want to do this. You don't want to just remove statistical outliers without being able to explain why they are there. Because the thing is, if we expanded our sample to the entire population, we might find out that a lot of people only study for 1 hour and it needs to be in there. So just something to be aware of. So now let's look at the density for this distribution. So again, this is code that we wrote in the last video. This should look familiar to you. If we run this, what we'll see is that bell curve that we generated before, but this time for the study hours. And this bell curve looks quite a bit different. This bell curve is what we call right skewed. And that means that most of the data is on the left side, right? Or less than 10 study hours. And so it causes the right side of the chart to be longer, to have a long tail. And those 3 lines in the middle are the mean, median, and mode there, which you can see are all sort of right around the middle point. So we've talked about the importance of knowing where the middle point is in the data, but there are some other measurements that data scientists use to gain insights about the data. These can be the range or the difference between the minimum value and the maximum value, something called the variance, and something called the standard deviation. Let's talk about those. In statistics, variance is described as the average of the squared differences from the mean. What does that mean? Well, let's calculate it and it'll actually make a lot more sense. It's not that complicated. So what variance is it's sort of a measurement of how far the data is spread out across the sample or how far away it is from the mean being the average. So first, let's just get the mean here. We know how to do that, right? So let's get our students, our study hours here, and then we'll just get the mean for the study hours. Now let's go ahead and calculate our variance. We're just going to start at 0 and we'll calculate it. And then what we're going to do is we're going to loop over all of the study hours. And we can do that here just like this with this for loop. And this will loop over all of the hours values in the study hours column. Let's just go right through that whole column. And then once we're in there, what we need to do is we need to subtract the hours from the mean. Okay, so for each row, we're going to subtract the hours from the mean. Some of those values are going to be negative, right? Because if the value is above the mean or the average, if the average is 10 and you studied 15, that's a -5. So to account for this, what they do is they square that number, which always gives us a positive number. And then what they do is they take the variance, they add all those numbers together to get what they need first off for the variance. So we're going to say variance equals, and then we're going to just add to what the variance already is. And we're going to say plus, and then order of operations, put all this stuff in parentheses so it does the right side first. And then the last thing that we have to do to get the variance, so variance actually equal to variance divided by, so this number we're calculating in the for loop divided by the total number of rows that we had in the loop. So we can get that by doing df students. And if you remember before, there's a shape method that we can call here that gives us the rows and the columns. And so if we just do 0, that gives us the number of rows, right? And so then let's just look at the variance value here. So we'll run this and we get 11.60738. What does this mean? Actually, it doesn't mean anything to us. Variance is a measurement that often means something to statisticians, but when we're working with the data, it doesn't mean a lot to us, and that's because we squared those numbers. So what statisticians do is they use a different measurement called the standard deviation. You've probably heard of the standard deviation before. And the standard deviation is just the square root of that variance. So to get the square root, let's just import the math package here, and then we'll just ask the math package for the square root function of our variance, right? And that should give us the standard deviation. So let's run this. And there we go, 3.4. Now what this means is that for one standard deviation, the value is going to be 3.4 away from the mean, either above it or below it. But what does that mean? Well, there's a number that you need to memorize here, and it's 68%. Just remember that number in your brain. 68% is the number that statisticians use for a normal distribution, right? When that curve looks relatively normal, we can say that 68% of the values in that curve will fall in one standard deviation. So 68% of the hours, the study hours, are going to be 3.4 above the mean or 3.4 below the mean. And that's the standard deviation. Fortunately, we don't actually have to calculate these things by hand, even though we just did. So instead, what we can do is let's loop over our columns here in, so we're going to loop over the grade column and the study hours column. And that's what this for loop is going to do. And then inside of that, whoops, Visual Studio Code telling me that's wrong. Let's fix that. And then inside of that, we're just going to go ahead and get the column from the data frame here. It's going to be either grade or study hours. This allows us to do that. And then let's calculate the range, right? Which we said was the max minus the min. Okay. And then let's go ahead and calculate the variance here, which we can just do like this, right on the column, and then we get the standard deviation the exact same way. And then let's go ahead and print out what that standard deviation is here, and the range and the variance. Let's run this. Okay, so we can see for the grade here that the range is 94 and the standard deviation is 21. And what that means is that we can do this. We can say, let's just print this out so we can actually look at it. But we can say 68%, right? That's the magic number you were going to store in your brain of grades will fall between, right? And then we need the mean minus the standard deviation. So let's just say df.students.grade.mean minus df.students.grade.standard deviation, right? That gives us the lower end, and then the upper end would be this same thing here. Let's go ahead and just copy this over. Okay, put this at the end and then change this minus, just reverse this sign. And then we can actually look at this and it should make more sense. So 68% of all grades will fall between 27 and 70, okay? And that's one standard deviation. And these calculations are actually all built into the data frame. So we can just describe the data frame here like this as a method. And that will tell us for each of these columns what the mean is, what the standard deviation is, what the quartiles are, the min and the max. Okay, so if you've made it this far, you now should understand concepts about the distribution of data, variance and standard deviation, range, mean, all of that stuff. Congratulations. Now that we know that, we can use that to examine relationships between variables in our data set. And this is where things start to get really interesting. So what we can do is define a new data frame here called df sample, and we're just going to set that equal to df students, and let's pull out where the study hours is less than 1, okay? And then let's go ahead and look at this data frame. In our data frame, we have a couple of different kinds of values, okay? We have numeric values and we have categorical values. The numeric values are study hours and grade, and the categorical values are name and pass. We can actually compare numeric columns to categorical columns to get some insight, and I'm going to show you how to do that. So first off, let's compare the study hours numerical value to the pass categorical value. So to make this comparison between these two values, let's go ahead and use a box plot. So let's go ahead and use our sample data frame, and we can call the box plot right off of the data frame. And then we need to tell it what column is it that we want as a bar, and we're going to say study hours. And it's got this nice little by a value that we can pass here, and we're going to say give it to us by pass, and I'll show you what that does here in a second. And we'll set our fig size equal to 8 by 5, which would be what? 800 by, that's right, 500 pixels. Let's go ahead and run this, and here's our box plot. Now, you can tell just by looking at this that the more that you study has a direct correlation with whether or not you passed the class or the exam. It's just readily apparent from looking at it, and probably common sense. You could have guessed that without a chart. But the real insight here is that the study hours might be a good predictive measurement for whether or not a student is going to pass the class. Now let's examine our numerical values and compare those. So let's take our sample data frame here and let's make a plot. And along the x-axis, the bottom, we want to have the name of the student, right? And you should remember this from the box plot we made in the previous video. Along the y-axis, I want to have 2 bars. We're going to have 2 bars for every student, 1 bar that represents their study hours and 1 bar for the grade. So to get 2 columns into the y-axis, we just need this array syntax here, and then we'll tell it, give us the grade and give us the study hours, okay? And then the kind of chart we want here is going to be a bar. And let's go ahead and set our fig size here equal to, let's just keep using 8 by 5. Perfect. All right, let's take a look at this. Okay, so we have a bar chart here, but it's kind of meaningless. And the reason it's kind of meaningless is that the scales for these numeric values are different. A grade can be from 0 to 100, whereas study hours don't go that high, right? I mean, study hours might be 20 is our time. In fact, we can go back up here and look and see when we described our data frame, what was the max amount of study? 16. Okay, and the max grade is 97. So they're not on the same scale, so we can't actually compare these values like this. So what we need to do instead is normalize the range for these values. And there's a lot of different ways to do that. We're going to use one called a min-max scalar. And what the min-max scalar does is it takes the range and it just normalizes it to between 0 and 1. 0 being the bottom, 1 being the max. And it normalizes both the grades and the study hours so that we can actually compare those two. So let's go ahead and create a new cell here. And we're going to use this scikit-learn.preprocessing here. And then we're going to import this min-max scalar. There it is. All right. So let's go ahead and create the scalar. And we want a min-max scalar. And then we're going to take and create a new data frame, which we're going to call df normalized, because we've normalized this data. And we're going to take our sample data here. Okay. And then what we want to do is we want to pull off the name, grade, and study hours columns, because that's what we're using in our bar chart. Anytime that you specify multiple columns that you want from one data frame to another, you got to use this kind of goofy double bracket syntax. All right, so we want the name, we've got the grade, and we want the study hours, okay? And then what we're going to do is we're just going to call copy, which is going to copy all that into the new data frame. It's a different way to create a data frame from another data frame. We're just selecting specific columns and copying the data over. Now let's go ahead and normalize this data frame. So let's say df normalized, and then let's tell it what columns we want to normalize. And remember, when you're specifying multiple columns in a data frame, you got to have that goofy syntax there. So we want the grade and we want the study hours. Okay, and then what we want to do is we want to tell it that these columns are equal to, and let's call that scalar, that min-max scalar, and we're going to say fit transform, okay? Because we're using the min-max scalar, and then we're going to pass in the normalized data set here with that goofy syntax. So normalize the grade and the study hours. Okay. And then the last thing we want to do is plot this out. So let's take our normalized data frame, call the plot here, X is name. This is exactly what we were doing before. Y, since we want both grade and study hours, we need the bracket syntax here, study hours. The kind is going to be bar, and the fixed size we will make 8 by 5. Okay, let's go ahead and run this. And now we've got a bar chart where we can actually compare these values. And again, you can tell just by looking at the chart that the number of study hours is directly correlated to the grade. I mean, you can tell that just by looking. The more hours you study, the higher the grade tends to be. If you study for just a few hours, or like this person here, the grade is really, really low. So there seems to be a correlation between study time and grade. And there is a statistical correlation value that we can get that will tell us the strength of the relationship between the number of hours that you studied and the grade that you got. So to do that, let's create a new cell here, and let's take our normalized data frame. Let's get the grade column here, and let's ask for the strength of the correlation to this other column here, which is study hours, okay? And then we'll go ahead and print that out. That's a 0.91 or 91% correlation, which is super high. The correlation value goes from -1, which means they're probably not at all related, to 1, which means statistically the probability is they are highly correlated. Correlation goes from a value of -1 to 1. -1 being they're probably not related at all, and a 1 being that there's a really good chance that these two things are related. And that 0.91 is almost a 1. That's a very high correlation. Now, you may have heard the phrase, correlation is not causation. And this is really important to understand because it's going to be super tempting for us to jump to the conclusion here that the more that you study, the higher the grade that you're going to get, that they're directly related. And even though the causation is high, that's not necessarily true. And we can actually see that just by going the other way and saying, well, because of the strength of the correlation, they studied a lot because their grade was high, which doesn't make any sense at all. So let's continue to examine this relationship here. Let's go ahead and take our sample data frame and let's create a new kind of plot here. Let's create a scatter plot. Let's set the title here to study time, if we can spell, versus grade. And on the x-axis, let's put the study hours. And on the y-axis, we'll put the grade. All right, let's go ahead and take a look at this scatter chart. Now we can put a line here to better see the relationship between the dots, the grade, and the study hours that shows the trend if we use something called a regression line. Now, stop for a minute. Do you remember when you were in high school and you took algebra and you learned about slope-intercept form? Remember that equation? Y equals mx plus b, and you thought, when am I ever going to use this? Well, hold on to something because we're about to use it. So our formula for slope-intercept form was y equals mx plus b. Please don't turn the video off. This is going to make plenty of sense here in a second. So in this equation here, y and x are the coordinate variables. We actually already know what the x and y values are, right? X is study hours and y is grade. What we need to do is calculate the slope of the line, which is m, and b, which is where it crosses over the y-axis. If we have all those values, we can calculate a new y point for the line based on each of our x values. And we actually call that variable fx because it's actually going to be a function that we pass these values into. It's going to give us back a new position so that we can draw a line of best fit, or the line that's best fit for the points. We also have to deal with something called an error. And the error is the difference between the actual y value and the new y value that we calculated for the line, the regression line that we're going to draw. And the way that we calculate the error is that we actually take and we find the difference between the actual y value and our new calculated y value, and then we square it. And remember, we square it because sometimes it will be negative, and this gives us a positive number. And this line gives us a line of best fit, and it's actually called a least squares regression. And the reason why is because we're trying to minimize the error. The error is squared and the line is a regression line. Still with me? Now, fortunately, you don't have to calculate any of this stuff yourself. You just have to conceptually know that it exists and how to use it to draw that line. Python will do the rest for you. So let's go ahead and use this SciPy package here and import the stats from that. And then what we'll want to do is let's create a new data frame called df regression. And from that, let's get our sample. And then we want to pull out the grade and the study hours. So let's pull in the study hours here and the grade, and then we'll just copy those in. That's that goofy double bracket syntax we talked about. And then we want to calculate the slope M and the intercept B, okay? So we can do that by calling this stats.line regress here, okay? This gives us the regression line, and we just need to tell it, well, what line are you trying to calculate? We need the X and Y values. What is the X value? So df regression, study hours, right, is our X value here. And then the Y value, study hours. And then the Y value is going to be the grade, okay? And this will give us the slope and the intercept. Now, unfortunately, it's going to give us a bunch of other variables as well. And we can actually see this if we mouse over. It's going to give us the slope, the intercept, the R value, the P value, and the standard error. So we can just go ahead because we need those variables or this function will fail. We'll get the R value, the P value, and the standard error. Even though we're not going to use those, we have to include them for this code to actually work. All right, so now on our data frame, we can have a new column that's going to be that new Y value, and we can say that's equal to Y equals MX, right? M times our regression of study hours, because that's the X, study hours, what, plus B, right? And that's going to be just out here plus B, because we already have the M and the B, which are being calculated for us. So let's go ahead and calculate our error here as well, or the difference between our new Y value and the old Y value. So our new Y value we have called fx, and we're going to just subtract the other Y value, which is the grade, and that will give us our error. And then let's go ahead and plot this. So let's do a plot. Let's make it a scatter plot. And this is the same scatter plot that we just made, where the X is study hours and the Y is grade. So now we want to plot that regression line. How do we do that? Well, let's use the plot item here, and we're just going to tell it to plot. And what do we want to plot? Well, we want from the regression data frame, what we want to do is we want to plot the study hours, right? But the line that we want to draw here is from our regression data frame. We want that new Y value. That's actually what we wanted to plot. And let's change the color here so we can see it a little bit better. We'll just make it cyan. All right, and then let's go ahead and show this, and let's see what we've got. Let's run this. And boom, there's our line of best fit. And hopefully this makes sense now. We used that slope intercept form to calculate these new Y values, and we connected all those new fxy values, and that makes the line. And that just shows us sort of the trend line here, so we can see that as study hours go up, so does the grade. Now again, we could have seen this visually without the line, but that's not always the case. Sometimes the line is very helpful to help you identify and visually see the relationship between these items. Now, I told you things were going to get super interesting, and here's where it's all going to come together for you. So you know these M and B values up here? I actually want to print these out, right? So let's just print M and B, our slope and intercept. So let's go ahead and run this. And we get 6.31 and minus 17. These numbers are important because we now have all of the information that we need to actually predict what a grade will be based on the amount of hours that someone studies. So here's how to write a function to do that. So we're going to have a new function here. Let's just call it predict. And then we're going to pass in the X value, right? The X is the number of hours that someone studied. So we're going to pass in that X value. We're going to calculate what their grade would probably be. So our M, if you remember before, we had the M and the B, right? So our M was equal to what? 6.31. It's right there above us. 34. The more decimals we include, the more accurate it will be. The B was equal to what? Minus 17.9164. Again, it's these two values here. And then what we're going to do is return mx plus b, okay? And that's going to help us predict the grade, which is that value on the line, right? That regression line, which is the line of best fit, which is most likely the grade that someone would get if they studied for a certain amount of hours. So let's go ahead and call that. Let's say our prediction here is, let's call our predict function, and we're going to pass in and say, well, what if they studied 14 hours? What would their grade be? And then let's just go ahead and look at our prediction. So our prediction is that if they studied 14 hours, their grade will be a 70. What happens if they study for, let's say, 20 hours? 108. So you can see here that we kind of need to cap this because it doesn't know that the highest grade you can get is 100, but essentially studying for more than about 18 hours, 95, right? So if you want an A in this course, you need to study for 18 hours. And if you've made it this far, you know a lot about data science, and you actually know something about machine learning as well because you just did it. You used a linear regression algorithm to make a prediction based on the amount of hours that someone studies. Thank you so much for sticking with me through this video series. Check the description in this video for more resources that you can go through on your own interactively to learn more about data science, machine learning, and artificial intelligence. Happy coding.